Hi, my name is Tawfiq Omar Uthman, math teacher. For our lesson today, I'll try to explain chapter 4, lesson 3, limits at infinity and horizontal asymptote. Please do not forget to subscribe the page and write your comment if you have any question and push the like button. Let us start our lesson. If x approach to the positive infinity, that means if the x become greater and greater, the limit of x approach to the infinity for fx is equal a, and if x approach to the minus infinity, that means when x becomes smaller and smaller, then limit is equal a. That means y equal a is an horizontal asymptote. Theory: if r is a positive rational number, then limit when x approach to the positive infinity, c over x to the power r is equal to 0. That means if you have a constant at the numerator and you have an function at the denominator, that means when x approach to the positive infinity, the limit is equal to 0. And x to the power r is defined when x is negative, then limit when x approach to the minus infinity for c over x to the power r is equal 0. That means if you have a constant and you have a function at the denominator which is defined when x is negative, so the limit is equal to 0. Example number 1. Find the limit when x approach to the positive infinity for 5 minus 2 over x square. Limits when x approach to the positive infinity, 5 minus 2 over x square, it become limit when x approach to the positive infinity for 5 minus limit when x approach to the positive infinity for 2 over x square. That one, the limit of constant is the constant, and using the theory it become 0. Limit when x approach to the positive infinity for 2 over x square, it become 0, so 5 minus 0 is 5. That means limit when x approach to the positive infinity for 5 minus 2 over x square is equal 5. Check it out. Number 1. Find the limit when x approach to the positive infinity for 5 minus 2 over square root of x. And now limit when x approach to the positive infinity for 5 minus 2 over square root of x is equal limit x approach to the positive infinity for 5 minus limit when x approach to the positive infinity 2 over square root of x. It become 5 minus 0, it equal 5. Example number 2. Find the limit where x approach to the positive infinity for 2x minus 1 over x plus 1. And now, because it is when we replacing positive infinities here is become infinity over infinity, so we must divide it both of the numerator and denominator by x with the bigger power, power at the denominator. Here is x to the power 1. That means we must divide it numerator and denominator by x. It becomes 2x over x minus 1 over x over x over x and 1 over x. And it becomes 2x divided by x is 2 minus 1 over x. X divided x is 1 plus 1 over x. It become limit when x approach to the positive infinity for 2 minus limit when x approach to the positive infinity 1 over x, and limit when x approach to the positive infinity 1 plus limit x approach to the positive infinity 1 over x. This one is become 2, and this one is 0, and this one is 1, and this one is 0, so it become 2 over 1, which is equal to. Here we have another way to solve this example by using the Hospital rule. So the limit when x approach to the positive infinity, we will take the derivative of numerator and denominator. So limit when x approach to the positive infinity, 2x minus 1, x plus 1 derivative, and now it become limit when x approach to the positive infinity. Derivative of 2x is 2, and the derivative of 1 is 0. At the denominator, derivative of x is 1, and the derivative of 1 is 0, so it become limit when x approach to the positive infinity 2 over 1, which equal 2. As you can see, is the same answer. And now find the limit when x approach to the minus infinity for 3x squared minus 2x plus 2 over 2x squared plus 3x minus 2. By using an Hospital, limit when x approach to the negative infinity for 3x squared plus 2x plus 2 by taking derivative and the derivative of the numerator. It become limit when x approach to the minus infinity. The derivative of 3x squared is 6x minus the derivative of 2x is 2, and the derivative of 2 is 0. And now the derivative of 2x squared is 4x, and the derivative of 3x is 3. Here, if we replace minus infinity, here it become minus infinity over minus infinity. That means we must take another time the derivative of numerator and denominator. Limit when x approach to the minus infinity for 6x minus 2 over 4x plus 2, and it become the derivative of 6x is 6, and the derivative of minus 2 is 0. The derivative of 4x is 4, and the derivative of 3 is 0. So it becomes 6 over 4, and by simplifying it becomes 3 over 2. Example number 3. Find each of the following 3 limits. A. Limit when x approach to the positive infinity for 2x plus 5 over 3x squared plus 1. By using Hospital, it become limit when x approach to the positive infinity 2x plus 5 derivative and 3x squared plus 1 derivative. It become limit when x approach to the positive infinity 2 over 6x. And now by using the theory, it become 0. It become limit, this limit becomes 0, because we have a constant at the numerator and we have a fraction at the denominator, so it become 0. But we are using another time the derivative. It become x approach to the positive infinity, derivative of 2 over 6x derivatives, it become 0 over 6. The 0 over 6 is 0. That means the degree of numerator is less than the degree of the denominator, so y is equal 0 is the answer of the limit, and it is an horizontal asymptote. It's an horizontal asymptote for this function. B. limit when x approach to the positive infinity, 2x squared plus 5 over 3x squared plus 1. By using the Hospital rules, it become limit when x approach to the positive infinity for 2x squared plus 5 derivative, 3x squared plus 1 derivative. And now by taking the derivative, the limit when x approach to the positive infinity, the derivative of 2x squared is 4x, and the derivative of the 3x squared is 6x. And now cancelling x with x, it become 4 over 6, and simplifying it become 4 over x is equal to 2 over 3. And if, as you can see, the degree of the numerator it is 2 and the degree of denominator is 2, so because the derivative of the numerator is equal the degree of the denominator, so the y is equal 2 over 3, or the limit is 2 over 3. That means the factor of x squared at the numerator over the factor of the x squared at the denominator. And if we say for general, y is equal a over b. A is the factor of the x with the greater power at the denominator, and b is the factor of the x with the greater power at the denominator, is the horizontal asymptote to graph of this function. And now that means y equal 2 over 3 is a horizontal asymptote for the graph of this function. C. Limit when x approach to the positive infinity, 2x cubed plus 5 over 3x squared plus 1. It become limit when x approach to the positive infinity, 2x x to the power 3 plus 5 derivative, 3x squared plus 1 derivative. By taking the derivative, limit when x is approach to the positive infinity, 6x squared over 6x, it become, taking another time the derivative, so it become limit when x approach to the positive infinity, 12x over x. Because we have x at the numerator, that means the answer of this limit is infinity. Maybe it is a positive infinity or a negative infinity. To know that, multiply the sign of the x here and the sign of the x here and the sign of the denominator. Positive time positive time positive, it is a positive answer. And now the degree of the numerator is greater than the degree of the denominator. Then the graph of this function does not have any horizontal asymptote. Maybe it has. If the difference was 1, that means if the degree of the numerator greater than the degree of the denominator by 1, so maybe it has a slant asymptote. And now horizontal and the slant asymptote. Y is equal 0 is a horizontal asymptote for the function if the degree of the numerator is less than the degree of the denominator. And y is equal a over b if the degree of the numerator is equal than the degree of the denominator. And maybe the function have y is equal, yani slant function, slant asymptote, if the degree of the denominator is 1 degree greater than the degree of the denominator. Let us see, does the graph of this function f of x is equal 5x cubed minus 2x squared over x minus 2x cubed have any horizontal asymptote? If yes, find the equation. As you can see, the degree of the numerator is 3 and the degree of the denominator is 3, so it has a horizontal asymptote. The degree of the numerator is equal to the degree of the denominator, so it has a horizontal asymptote, and y is equal a over b, which equal y is equal a is 5 here, and b is minus 2. B is minus 2. So y is equal 5 over minus 2 is an horizontal asymptote, and the limit is equal minus 5 over 2. Example number 4. A. Find the limit when x approaches to the positive infinity 3x minus 2 over square root of 2x squared plus 1. Here we are to find this limit, we must divide it both numerator and denominator by x. It become limit when x approaches to the positive infinity 3x over x minus 2 over x and square root of 2x squared plus 1 over x. And now changing this x to the square root of x squared, and here cancelling x with x become 3 minus 2 over x, and this one it becomes square root of x squared, and taking this x squared under 1 square root, it become limit when x approach to the positive infinity 3 minus 2 over x square root of 2x squared plus 1. And now it become limit x approach to the positive infinity 3 minus 2 over x 2x squared over x squared plus 1 over x squared. Limit when x approach to the positive infinity, it become 2 minus 2 over x square root of 2 plus 1 over x squared. And the limit of 3 is 3, and the limit of minus 1 over x is 0. The limit of 2 is 2, and the limit 1 over x squared is 0. So it become 3 over square root of 2. That means y is equal 3 over x square root of 2 is an horizontal asymptote on the right of this function. As you can see, here is y is equal 3 over square root of 2 is the horizontal asymptote for the function at the right side. Here we have an notation. As you can see, the power or the power of x is here is 1, and the power of x is 2 here. By taking the square root, this power is become 1. That means the degree of the numerator is equal to the degree of the denominator. That means it is equal. So a is 3 and b is square root of 2. And now to find this limit at the fast way, only multiply this sign positive and the sign of x here, the sign of the x with the greater power. Positive times positive is positive. And now multiply the answer with the sign of the square root, which is positive. That means positive times positive times positive, it is a positive. And now take 3 and under square root 2. Square root of 2. This is the answer of this limit. Check it out. Number 4. B. Find the limit when x approach to the minus infinity over 3x minus 2 over 2x square. We can use the first way, which is limit when x approach to the positive infinity, by dividing each of numerator and denominator by x. It becomes 3x over x minus 2 over x and square root of 2x squared plus 1 over x. And now changing this x to the minus square root of x squared, because x is here is negative, so this one must be the negative. And now taking this x squared under the square root and finding the limit, it become 3 over minus square root of 2. And now by using the fast way, it become by multiplying this minus with the positive, minus time positive is minus, minus time positive is minus, so it become minus. Here we have 3 and here we have square root of 2. That means it's minus 3 over square root of 2. Y is equal minus 3 over square root of 2 is an horizontal asymptote on the left, as we seeing the graph at the graph of the function. Y is equal minus 3 over square root of 2 is a horizontal asymptote on the left of this function. And now find the horizontal asymptote to the graph of this function. Because we have square root under the or at the denominator, so we have two horizontal asymptote. One of them, by multiplying plus time plus time plus, it become plus. Here before x we have 5, and here before x squared we have square root of 3, so it become 5 over square root of 3. Then y is equal 5 over square root of 3 is an horizontal asymptote on the right. And if we have approaching to the minus infinity, so minus time plus is minus, time plus is minus, so it become minus 5 over square root of 3, and y is equal minus 5 over square root of 3 is an horizontal asymptote on the left of this function. Here we reach goodbye. Please do not forget subscribe the page and write your comment if you have any question, and push the like button. Thank you for watching and goodbye.